In this video, I will demonstrate how to find the inverse of a rational function. We have the one-to-one function f of x is equal to 3 divided by the quantity x minus 6 given, and we want to write the equation of its inverse. We first replace f of x with y to get y is equal to 3 divided by the quantity x minus 6. Then we have to interchange the variables x and y. This gives us x equals 3 divided by the quantity y minus 6. Now our goal is to solve this equation for y. We first begin by multiplying each side by the least common denominator, y minus 6, or you can think of it as also cross-multiplying. In any case, we would get x times y minus 6 is equal to 1 times 3, or 3. Distributing on the left, we get xy minus 6x is equal to 3. To solve for y, we need to get the term with y by itself. So we're going to add 6x to each side. So we get xy equals 6x plus 3. And now to solve for y, we can divide each side by x. So we get y is equal to the expression 6x plus 3, all divided by x. Therefore, this is our inverse function, which we denote by f inverse of x is equal to 6x plus 3, all divided by x. Now to confirm, we can go to our calculator. If we input the first function into y1, which is 3 divided by, in parentheses, x minus 6, and in y2, we will input the inverse, which is in parentheses 6x plus 3 divided by x. And then in y3, I have y is equal to x because those two functions should be symmetric about the graph of the line y equals x if they're inverses. So when we look at the graph, notice that the function in blue is the graph of the original function. There is a vertical asymptote at 6 and a horizontal asymptote at y equals 0. And when we look at this line y equals x, we can see that the graph in red, which is our inverse function, is symmetric about that line. Notice that that particular function has a horizontal asymptote at y equals 6 and a vertical asymptote at x equals 0. So even the horizontal and vertical asymptotes are interchanged in the inverse functions. We can see it maybe a little bit clearer when we look at the table. Again, recall that the ordered pairs are interchanged. If xy is on the graph of the original function, then yx is on the graph of the inverse function. We can see a few of these points. Notice that in the original function we have 3, negative 1. So on the inverse, we would want to find negative 1, 3. We also see 5, negative 3 is on the graph of the original function. And so on the inverse, we should see negative 3, 5. And we do. That confirms that our function that we found is indeed the inverse of the given function.